In the first lesson from 7-7, you were working with how to write out the imaginary number and simplifying those expressions. And now we're going to start working with them and doing operations with them. The first lesson here in lesson 2 is multiplying and dividing complex numbers. When you look here at this, the first example I have for you is the square root of -2 times the square root of -7. When you have an imaginary number, a negative on the inside of the square root, you must deal with that first. So when I write this out, I would then say that this is I times the square root of 2 times I times the square root of 7. And now I can use my quotient rule with my radicals. I know maybe some of you might even think, oh, that's the square root of 14. No, you have to deal with the I, the imaginary number, first. So those are written first, and then we write a radical number. Now I can see I have I, this is all multiplied, I times the square root of 2 times I times the square root of 7. So in my next step then is to write I squared times the square root of 14, because now I can do the 2 times 7 for the square root of 14. I also know that the I squared, and if we look back at your chart from lesson 1, you'll see that I squared equals -1. So now I can change that, and I can say that this is the opposite of the square root of 14. And then I would be done with that. Since I squared can be changed to -1, I'll change that. And then the square root of 14 doesn't have any perfect squares, so at this point, I have now multiplied the square root of -2 times the square root of -7. Next example is also a multiplication one. Now I have the square root of 27 times the square root of -3. The first thing that I need to do is I need to deal with the I inside this negative square root, and if I look at 27, I know I have a perfect square factor there. So to look at this one, I'll take the first factor here, the square root of 27. I'm going to rewrite that as the square root of 9 times the square root of 3. And then it's times I times the square root of 3. So again, I have 4 factors here now. So I know the square root of 9 to be 3. I have a square root of 3 times the square root of 3. That will be 3. So 3 times 3. And then I have that factor of I. And now I can do 3 times 3, which is 9. So that this is 9 times I, 9 times the imaginary number. And since it's just plain I leave it as I. Another example that I have for you happens to be one where now we're dealing with division. The square root of -8 over the square root of 2. So let's take a look at this. If I look here, first, I'm going to deal with that imaginary number. So I say I times the square root of 8 over the square root of 2 equals, now I have a perfect square factor inside the square root of 8, so I have I times the square root of 4 times the square root of 2 all over the square root of 2. I have a square root of 2 that's multiplied in the numerator and a square root of 2 in the denominator. So now that means they will cancel because that's like square root of 2 over square root of 2. So that equals 1. So those cancel. And then I'm left with I times the square root of 4. And the square root of 4 is 2. So I say 2I. Okay, so now that is a division problem for us. If we can simplify, we can. Here's a second one for you. Again, using in this time, I now have I in the denominator. In the first one I had I in the numerator, now I have I, it's going to appear in the denominator. So looking at that, the square root of 81, well, that's a perfect square. That's going to be 9 all over. All right, I have I times the square root of 5. So what do I do next? Well, I don't want that denominator to have an irrational number in it. So I'm going to rationalize it, and I'm going to take it times the square root of 5 and the square root of 5, as we've done in our other previous lessons. And at this point, I have 9 times the square root of 5 on the numerator. And in my denominator, I have I times the square root of 5 times the square root of 5. And I know square root of 5 times square root of 5 is square root of 25. That happens to be 5. So I have 5 and I. And yes, you can have the imaginary number in the denominator. That's fine. So at this point now I'm done. We just don't want an irrational number in the denominator. So in a lot of ways, you kind of have to treat I like a variable here. I can't cancel anything out. So I have to take a look at that. This is 9 times the square root of 5 over 5i, and I'm done. Okay, so a few problems to do here. Take a look, I'll scroll this down. I want you to do page 466 and numbers 9 through 18. Please check your answers with my textbook and notice there are even numbers here, so you should be grabbing my textbook when you correct, and then turn it in as soon as you finish. All right, let me know how I can help you with this.